abrogated means like that.
Okay, we're going to be talking about 31, so if you don't have that out, go ahead and get it out. You were asked to do the next 5 problems the last time we left. You've had quite a bit of time to play with those, so I hope you have gone through. We're going to hopefully quickly go through, look at the answers, be sure everybody can get to the right place with that, and then we're going to continue talking more about udo substitution today. I haven't looked to see that you did the video problem Wednesday night. I'm certain you did. If you hadn't, get it done. FRQs are due today. I'm certain you won't get them turned in today. That's all right. Get them done. You do have a web assigned due Monday night, okay? Now, it's over substitution. We talked about it a little bit. We're going to talk about it again today. You should have the capabilities of doing everything on that. Monday we'll be back to a more normal schedule, so we'll have an opportunity to ask some questions, probably one of the class periods on Monday. So let's look at these problems that you had. If you go back and remember with substitution, we're looking to change it into a function that we can integrate, because so many of the functions we look at we cannot integrate. Well, if we're looking at this particular function here, or when we're looking at how do we know what we want to substitute in? What are some things we look for? What's in the parentheses, and we've got to have the derivative of that thing somewhere. Those are what we look for. So when we look at this particular problem, what's in the parentheses? 3x minus 1. We let u be that. Remember, how do we determine what du is once we decide what u is? Derive u. We do not look back at the original problem and pick du out of there. We derive u and find out that it's 3dx. Once we do that, then hopefully we'll see that, oh, this is already in the problem, and this is in the problem. So suddenly we can simply plug in place of 3x minus 1, we can plug in u. And in place of 3dx, we can plug in du, and the function integrates to be u to the 5th over 5. We have to plug our x's back in and get 3x minus 1 over 5 to the 5th. Okay? Any questions there? All right, looking at the second one. If it'll ever move. Wonder if it will. Well, when it rains, it pours.
I've never heard that other than the
Okay, so let's look at the next problem, if it'll do that for us. And if it won't, I'm just going to throw my hands up in the air. Okay, here's the second problem. Now, we've got 2 parentheses. We've got 2 parentheses, so what does u need to be?
Spoil it out.
Right. You could FOIL it out to begin with. And if you FOIL it out, you would not need to do any udo substitution. However, that answer is not going to be in your multiple guess, I can tell you, whatever you get by FOILing it out. But if you look at this and notice that when I do the u is x squared plus 1, if I put that in, then du is the derivative of that, and it's there. So then once you recognize that it's a simple problem, the answer should be x squared plus x, quantity squared over 2 plus c. Yes, sir? We let u be this particular thing. Then when we take the derivative of it, we see, oh, here's the derivative right here. You with me there?
So the one that isn't the derivative is going to be
Correct.
100% of the time.
Uh-huh. Yes.
Yeah.
All right. Connor, you okay there? All right. Now, with C, we don't have a parentheses written, but it's an understood parentheses with the square root symbol. Remember, anything that's grouping a group, we consider that as a parenthesis. So we let u be x cubed minus 2. So then our derivative is 3x squared, which is there. And if we integrate that, we should get 2/3 x cubed minus 2. Whoops. To the 3/2. I forgot that, didn't I? Yep, to the 3/2 plus c. Comfortable there? Nothing too challenging yet, I hope. Good. Jeez, I hate when it's slow like this. Now, a fraction. One of the first things you may think, okay, we'll bring it up, which we can do. Again, still look for the same thing. Where are my parentheses at? It's in the denominator. I'm still going to try to let that be my u. And if I let that be my u, then du is negative 4x, which is in the numerator. Something to note here, okay? Du must be in the numerator. Okay? That's too many humps there on the but you get the impression that it must be in the numerator. If that negative 4x is in the denominator, this is an unsolvable problem for us. So it must be in the numerator. If it's not in the numerator, you can't solve it. But we move that up. When we move it up, remember the exponent becomes negative, u to the negative 2. When we add 1 to negative 2, we get negative 1, not negative 3. The 1 to this to cubed is going to be in your answers because that's a common wrong mistake. So it should be u to the negative 1 divided by negative 1. And I would simplify that as negative 1 over 1 minus 2x squared plus c. Okay? And finally, we had one trig problem there. Cosine squared sine. How do we decide which of these to let u be? The one that has a larger exponent. We have cosine squared. Since we have cosine squared, we're going to let u be cosine. So since u is cosine, du is minus sine. Now remember, if minus sign is not there, which in this case it's not, we can simply divide both sides of this by negative 1, and we get negative du equals sine x dx. So in place of the sine x dx, I put du and a negative sign. I just went ahead and put the negative sign on the outside because I know it doesn't change what I'm doing. And in place of cosine, I put in u, so it becomes u squared, and then when we integrate it, it's u cubed over 3. Don't forget the negative sign. Because the derivative of cosine is minus sine. So then we have to have a minus sign in our problem. We divide both sides and we can simply move the negative sign all the way out front. Okay? Comfortable there? All right. We're going to just add a little bit to it today. Now, what does the 0 and 1 on here, what are they called? Does anybody remember terminology? Limits of integration. Yes, these are called limits of integration. What does it mean? Who remembers what we call it if it has numbers on it? What kind of integral? Almost specific. It's a definite integral. It's a definite integral, okay? Now, I have a question for you. What does it change about your answer? You're not going to have a C, and we should wind up with just a number in the end. Now, how do we get that number? We integrate and then plug these in for x, right? Okay, so now, let's decide here. What should be our u for this problem, do you think? X squared plus 1. So then du is 2x dx. Well, I don't have a 2 over there. Right. So if I just divide both sides by 2, then I can say 1/2 du equals x dx. So now in place of the x dx, I can write down du, and I'm going to put the 1/2 outside the integral. Why can I put the 1/2 outside the integral? It's a constant. And in place of the x squared plus 1, I'm going to put u cubed. Very important. Do not put 0 and 1 on there as limits of integration. It is wrong if you put the 0 and 1 there. Right. These numbers are what x, when x is 0 and when x is 1. So we don't put 0 and 1 there. We leave it as an indefinite integral. So we've simplified the problem. In place of x squared plus 1, we put u. In place of x dx, we put du and the 1/2 in there. How do we integrate that? Or what do we get when we integrate? U to the 4th over 4 times the 1/2. Very good. And again, we aren't going to evaluate it at 0 and 1 because 0 and 1 are x values, correct? So what do we need to do now? Plug it back in. I'm going to write this as 1/8. Where did the 1/8 come from? 2 times 4 is 8. And this is what? X squared plus 1? Now I can evaluate that at 0 and 1. Oh, it should be, shouldn't it? Thank you, ma'am. I'm a little bit slow today. X squared plus 1 to the 4th. Because it's u to the 4th over 4. Now I put the 0 and 1 because we're back to x's. So we can use the 0 and the 1. And if we simplify that, we get 1/8 times, if we put 1 in there, 1 plus 1 is 2 to the 4th is 16. Minus 0 plus 1 is 1 to the 4th is 1. So we get 15/8 for an answer. We okay with that? You can do the 1/8. You can distribute that, or you can do what's inside and then multiply it by 1/8. You're going to wind up with the same thing either way.
We're going to do the thing where it's the first part is the bigger number, then the minus the little number. We already do that.
We just did that. Oh, yes, we do now. Look, if we put the 1 in, 1 squared is 1, plus 1 is 2, 2 to the 4th is 16. I did it all in my head. I didn't write down anything, okay? And then when I put the 0 in, 0 squared is 0, plus 1 is 1, to the 4th is still 1. So I did it all in my head there. If you need to write it down, close your ears and write it down. Okay? What does this mean about the graph of x squared plus 1 to the 3rd? Most of it's above the x-axis. This 15/8 represents the what?
The area.
The area from 0 to 1, okay? Keep that in mind, okay? We're going to evaluate this at 1 and 0. 1 squared is 1, plus 1 is 2, 2 to the 4th is 16. 2 times 2 times 2 times 2. Okay? I am recording this, Amanda, so if you want to look at it later, you're more than welcome to. All right, any questions there? Clear? Good. Solve the problem. Try this on your own, then we'll come back and talk about it. Think about what your u needs to be. Say that again. Uh-huh. Here's 16 over 8 minus 1 over 8. Let me see. Yeah. Because when you put the 4 in, you get 16. When you put the 1 in, you get 1. When you put the 1 in, you get 16. When you put the 0 in, you get 1. Think about what your u is. No. Oh, yes, it is. Ooh, terrible, it is, isn't it? What's our u going to be? 2x minus 1. All right, so when we do that, then that's u equals that. So then du is 2dx. And when we look back at our problem, we don't have a 2dx over there. We have an x. So that's a clue that we do what?
Divide by the d. Wait, can you do that?
No, we can't divide by the du.
Solve for u or what? Solve for x?
Right. Now we need to take this top equation here and solve for x. So if we do that, we get u plus 1 equals 2x. So u plus 1 over 2 equals x. Now we've got all kinds of stuff we can plug in.
It's u equals 2x minus 1.
U equals 2x minus 1, so we add 1 to both sides. I just looked at this particular problem up here. Now why did it do that? That was terrible. Absolutely terrible. Just added 1.
Not like you, but
It does not.
mine really does, though.
Yeah. So now let's substitute in what we can over there. In place of that x on the numerator, what can you plug in? Okay, so we're going to put u plus 1 over 2 there. In the bottom, what can we put in? Yeah, we can. What can we put in for 2x minus 1?
It's unsolvable.
U plus 1.
What can we put in for 2x plus 1? U. So on the top, we can put in u plus 1 quantity over 2. On the bottom, we have the square root of u. And then we got to figure out what to do with our dx's. Hopefully we're going to come back here with it right now. If my computer will decide to cooperate. I think it's telling me to go buy a new one. All right, so let's get back up to speed here. We had said let u equal 2x minus 1. So that means du is 2dx. So then we took this equation and solved it, and we said u plus 1 equals 2x. So u plus 1 over 2 equals x. So now we can go over here and plug in. What are we going to put in for this x? Well, we'll put u plus 1 over 2. What are we going to put in for 2x minus 1? U. So we have the square root of u. What can we put for dx? Well, we don't have dx equals to anything. But what can we put in place of it? du is 2 dx's. So what could we do? If we divide both sides by 2, for dx we could put 1/2 du, right? What 1/2? Yes, I'm about to bring it on all the way out. Actually, I'm about to rewrite it like this. I'm going to say 1/4 u plus 1 times u to the negative 1/2. Now, I may have just blown your minds, but don't freak out yet. Look and see if you can figure out how I did that.
Got rid of the 1/2. What did you do?
And then you multiply the 2 to the other side.
All right, let's go through the steps of how I got here. Here, okay, I had dx, and in place of dx, I can put 1/2 du. So that's what I substituted in here. Are you with me there? Now, how did I get from this statement, this line, down to that line? That's the question. Du was the derivative of this thing up here, which was 2 dx. But we don't have a 2 up here. So we decided to divide both sides by 2. Since it's a constant number, it's legal to do that. We divided both sides by 2. Then in place of this dx right here, we can simply put in this expression right here, 1/2 du. I'm just doing some algebra substitution there. And now I can say Well, I've got a 1/2 right here. And this quantity right here is the same as 1/2 times u plus 1 over u to the 1/2 times a 1/2. Now I'm going to take this 1/2 and this 1/2 outside. That's where I got the 1/4 from. The u plus 1, and I've got a u to the negative 1/2. I still can't integrate that thing as it's written, though. We need to distribute and make it u to the 1/2 u to the negative 1/2 du. Not quite. We need to integrate. U to the 3/2 over 3/2 u to the 1/2 over 1/2. Notice I'm still not putting any of my limits of integration because they're dealing with x's, and I don't have x's back in here yet. Yes, this one was negative 1/2. I didn't write it, but I thought about it over here. Remember, this is the hardest ones we see right here. This is the challenging ones. Now can we clean up all of this mess here somehow? I'm going to leave the 1/4 on the outside, and then that becomes 2/3 u to the 3/2 plus 2 u to the 1/2. And now we need to plug back in for x's, don't we? U was 2x plus 1, I think. Okay. 2x minus 1 to the 3/2. 2x minus 1 to the 1/2. And I can evaluate that at 1 and 5. Wasn't that fun? Trust me, that's the hardest ones as far as algebra hard that you'll ever see.
Ever?
Mm-hmm.
Kind of not random, but like on the register, I feel like I know how to do these when I'm doing my YouTube, and on the other side I did several, and I would get them wrong. So I feel like I'm missing kind of like.
That's how I tell this entire year.
Okay. All right, we'll probably have time for me to look at some specifics with you in about 20 minutes. So now let's be sure we plugged in the right thing, 2x minus 1. So now it's a matter of evaluating. 2 times 5, 10 minus 1, 9. So we're talking about the square root of 9, which is 3 cubed, which is 27. So I'm going to make this 2/3 of 27 plus the square root of 9 is 3, 2 times 3. Yes, I could write down 6, but I'm trying to give you as many steps as I can. Minus 1/4. What happens when I put 1 in here? 2 times 1 is 2, minus 1 is 1, and 1 to the 3/2 is 3/2, so I get 2/3 plus square root of 1 is 1. And now that we have that, with a little bit of luck, we can figure out what we're doing here. 2/3 of 27 is 18 plus 6 is 24. 1/4 of 24. Two-thirds plus 2 is 8/3 times a 4th. A 4th of 24, I think, is 6 minus 4. This is minus. This is times right there, yes, I'm sorry. Because it's 1/4 times this thing here. That's not right. That's not 8/3, is it? 2 and 2/3, yes it is, yes it is. Okay, 8/3. And 6 minus 4/3 is 4 and 2/3 or something. No, that's 14/3. That's terrible, I know. The algebra, the arithmetic is not fun there, okay?
This is like watching a Hallmark movie.
Say what? Ah, yes. 1/4 times 8/3. Thank you, sir. That should be 2/3, which makes this over 16/3. So, sorry. Thanks, Sam. Be glad. I haven't worked the problem yet where I run out of paper in Smart Notebook. I have done that before. I've kept working down the page to the extend page, stopped showing up. It said, you got to go somewhere else. I don't know. I don't know. 16/3. 16/3. Okay? So, there we go. This is the problem that you hang your head with right now. That's okay. You can look back at it later. Some of it will sink in, okay?
Not hang my head, hang my head.
All right?
So, like when we say
Uh-huh. Mm-hmm. Yes. Yes. There's 6 FRQs, and then there's all the multiple guesses. Fortunately, something like this, I would not anticipate being on an AP exam, because this takes 5 minutes to do. You need to work every problem in about 2 minutes. But you do get a whole 15 minutes on the each FRQ. I mean, right? Yeah. So. You'll get better at it. Okay. Let's move on to a couple more problems here. The more you do this, the better off you're going to be. Okay? So, how do you think you want to attack this? All right? So, if we let u be sine x, now, finish it off from there. Determine what your du is. Write out what your problem becomes. The derivative of sine is cosine, right?
Well, why is it just sine x? How did you determine that?
Oh yeah, why did you then
get back out of sine of x?
Okay. All right.
The highest.
Mary Catherine said the higher exponent, that's what we normally do. So let's go with that. I think she's right there. All right. We let u be the sine of x, du be the cosine of x dx. All right. The problem is we've got 2 cosines in here. Yes. I think Brandon said that back a while ago also. What if we factor out a cosine, and to make it look like what we're trying to integrate, I'm going to write the cosine x dx over here. Okay? So then that's going to leave me with sine cubed of x plus the sine of x. Now look at what we've got now. For this right here, we can put du, can't we? All right, for the parentheses, what can we put for just the lone sine x? U. And what can we put for the sine cubed? U cubed. Now that's a lot neater problem to look at than that initial one. Now we can look at that and know it's u to the 4th over 4 plus u squared over 2. Are we going to evaluate this at pi over 2 and negative pi over 2? No. We're going to put in what for u? Sine x. So the sine of x to the 4th over 4 plus the sine of x squared over 2. And we've got to evaluate that at pi over 2 and negative pi over 2. So the sine at pi over 2 is 1. Remember, sine at pi over 2 is your thumb. Sine is to the right. So we're talking about 1 over 4 plus 1 over 2 minus, what happens at pi over 2? Where's pi over 2 on the unit circle? Between what two quadrants? Do you remember? Negative pi over 2 is down here. It's between 3 and 4. Okay? Talk to me about the sign, the positiveness and negativeness of the sign. It's negative. So it's going to be negative 1 over 4 plus negative 1 over 2. And if you'll look at it, I've got a 1/4 plus a 1/4, which gives me a 1/2. And I've got a 1/2 plus a 1/2, which gives me a 1. And I should wind up with 3/2 for a final answer there. You should be able to do that without a calculator on an AP test. That's right. You've either learned the unit circle or you can do hand trig. In that case, you have problems. That could be. Are we comfortable there? All right, let's just look at a couple more. You can do that. You can do that. Go ahead and solve that problem without any help from me. But you can't have a hot plate. I'm afraid so. Yes. Oh boy. Ooh. They didn't rub that in at all, I'm sure. So we're just integrating u do, and we get u squared over 2 plus c. 8x squared plus 1 over 2 plus c. Yes? Yes, ma'am. Thank you. I'll be right back to you there. That's squared. So that's cubed over 3. So that's cubed over 3. Okay, sorry about that. These things happen. Had 2 days away from calculus, and look what my mind has become. All right, do you? Okay, all right. So you understand it if I do it right. All right, let's see if we can find any others to be. Answer me this. Is that the really long, hard one or not?
It is not.
Why not?
Well, you don't have to plug them in.
Because it's x squared.
The derivative. Exactly. The derivative of this is 2x, so you'll just do the 1/2 du to plug in. Good. You can see that. Good. Is that hard?
No.
Ooh, both of them have the same power. What about it? Very good. The derivative of tan is secant squared. So no. Let u be the tan x. Then du is derivative of tan is sec squared x dx. Just tan because the derivative of tan is sec squared. We don't have a derivative for tan squared. U squared du when we plug in, so it becomes u cubed over 3. Tan x cubed over 3 plus c. Okay? That doesn't have to be as complicated there. Be careful with that. That's not hard. There's one I wanted to look at here. There's 2 I want to look at, this being one of them. 17? Do something with this one here. This one's a little different than anything we've done before. This is 21. I don't know which slide it is, but the integral of 5x.
Would that be 1 minus x squared and then 2x?
Yes, you could rewrite this as 5x 1 minus x squared to the 1/3 power dx. What is your u here, Grant?
1 minus x squared.
1 minus x squared. So what's du then? Negative 2x dx. But we don't have negative 2x over there. We have 5x over there.
Would it be negative 2.5 du?
Oh, wow. Y'all listen to Brandon for a second. Say that again. So if we say negative 1/2 du equals x dx. Well, that's close, isn't it? But we need a 5 in there. So he said we can go back now and multiply both sides by 5. As long as it's constant numbers, yes. If you do that, now you've got negative 5/2 du equals 5x dx. Uh-huh. As long as it's got a negative sign in front of it. So, exactly. So now when I integrate, I got negative 5/2 integration. 5x dx just becomes du out here, and it becomes u to the 1/3. So when I integrate, that's u to the 4/3 divided by 4/3, all with a negative 5/2 out here in front of it. Whatever all that's just a bunch of ugly stuff to do. Yes, sir?
Why do you have dx for the u?
I shouldn't. Buddy, I don't want you right now. Okay. There we go. So our answer would be what? Negative 15/8 1 minus x squared to the 4/3 plus c. These can get very ugly looking answers. But we're honing in on your algebra and arithmetic skills better here. Decimal, you could, but it won't be. You will not see that in the multiple guess. I will. Decimals are a no-no. Okay. Is it on down the line there?
Yeah.
Yeah. I think I know the one you're talking about.
Yeah.
All right. We okay to move to another one here? That one is straightforward. That one is straightforward. What do we do there? What's u?
One plus.
So what's du then? 1 becomes what? 0. This is the same as 1 plus t to the negative 1, isn't it? What's the derivative of t to the negative 1? Negative 1 over t squared dt. There you go. So y'all were ready to give up. And see, it's not as complicated as you might think that. Okay? All right, I'm not going to finish it off because that's the hard part there. I just want you to see that. See, don't be afraid of this stuff, okay? It's only twice as hard as you think it is. What do you do here?
And you pull it up and then that too.
Pull it up.
Pull it up and distribute? Yeah. But if we do that, we won't have to do it. So, that's not a problem. Yeah, it's okay. Yeah, that's quite all right. Just because we're doing udo right now doesn't mean everything has to be that way. I'm not going to, when the engineer brings you a problem to solve, he's not going to say, now you use udo substitution to solve this. You have to be intelligent enough to figure out which one you use. So we're just going to distribute this through, and we get x to the 5 halves. Ah, jeez. It will, thank you. Negative 1/2 when you come up. So it'll be x to the 3 halves plus 5x to the 1/2 minus 8x to the negative 1/2. That's what we're integrating. And we don't have to do any udo substitution. We simply integrate that puppy just like it is. So you should wind up with 2/5 x to the 5 halves plus x to the 3 halves, 10/3 x to the 3 halves minus 16x to the 1/2. Yes, that's ugly numbers I have to deal with. Yeah, the plus C is easy to forget, especially on web assigns.
You know all about that, right?
No, I got automatic stuff.
Oh. All right, this is one I want to look at, and then we'll find the one that Jason wanted to look at here. Solve the differential equation. What does that mean, dude? What does that mean? How do we solve it?
When they find the derivative, there's reference to the derivative.
The derivative is this. So what does it mean? What's the original? Just integrate is all that's saying. So we've got to integrate this thing. This is a fancy way of saying integrate. Now, if you will look at this as two problems, you will see how to do it real easy. Very good. If you see it as two separate problems, that's easy. The integral of 4x, all of you know what that is. Right? 2x squared. Okay? We didn't have to do any udo substitution for the first one. We will have to do some udo substitution for the second part there, okay? There's one just like that on the web assignment, if I'm not mistaken. Yep. In fact, it may be that problem. I don't know. U is 16 minus x squared. du is negative 2x dx. We've got a 4 up there. What are you going to do with that now? If we multiply both sides by negative 2, we get negative 2 du equals 4x dx. So now we've got something we can plug in for, don't we? It's the integral of du, negative 2 on the outside, and I've got u to the negative 1/2. So when we integrate it, we get u to the 1/2 divided by 1/2, which becomes that ugly mess there. 2x squared minus 4, 16 minus x squared to the 1/2 power plus c. No lit. Leave it like it is lit. Now, Jason, did I work the problem you wanted to look at or not?
No.
Okay, where's the one you... Okay, yes, sir.
I think I understand how to do this. There's this little rule that I forgot on the other time. So I would do it.
All right, we'll go back and fixing to turn y'all loose and let you work on web assigned stuff. You will have an hour of question asking and problem solving on Monday. Jeez, we only meet once on it, so that's what your hour will be on Monday. But Tuesday, Wednesday, and Friday of next week, we're going to have lectures. Okay, we're Nah, we're going to throw that away. We can't do that right now.
Yay.
Sorry, we just can't get that done. All right, what's your questions?
Remember the one you
Okay. You remember which one?
no,
Still back before that? Okay. Oh, back before even today?
yeah,
Oh, okay, okay. Oh, that right there. So what should u be here? X squared plus 3. So then du is 2x dx. So we'll have 1/2 do equals x dx. You with me there? Yeah, sorry. 1/2 integral of u squared du. So it'll fall out pretty easy. So you've got about 20 minutes now. You can work on whatever problems you may need to be working on. I'll be glad to try to answer. WebAssign Monday, WebAssign Thursday, and FRQ. That's your focus right now, okay? Those 3 things. You have the technology to do both WebAssigns at this point in time.